So in this second part of class, we're going to learn about regression. And so specifically, we're going to focus on performing and interpreting the results of a regression analysis. And then after that, summarizing our results using APA format. So in the first part of our class, we learned about correlation. So now we know how to determine if there's a linear association between two variables. So what regression does is it uses an equation to describe the linear correlation between two variables. Now, we should only do regression analysis if there is a significant linear correlation between the variables. And then what we do is we use technology to find the important components of the equation, namely the y-intercept and the slope. So the regression line has an equation, and it's used to make predictions about future observed values. Now, I know this is going to bring flashbacks to some of you. For some of you, positive flashbacks. For some of you, negative flashbacks, possibly neutral for some of you. But just remember, thinking back to your experience with algebra, you know that the equation of a line has this format: y is equal to mx plus b. So, buried deep in a brain cell somewhere, you know that that's the formula for the equation of a line. Okay? So, just as a reminder, x and y are variables, m is the slope of the line, and b is a number. Another word for a number is a constant, and it is the y-intercept of the line. Now, please don't worry if these concepts are fuzzy in your memory. We're going to go over it, and we'll only go over the important parts for this class, not all the gory details that you might have studied when you studied algebra. Okay? So here's an example of a regression equation. So this was data about the width of a book and the number of pages. And so this is a equation that allows you to predict the width of a book if you know how many pages it has. All right, so a couple of things. In statistics, if you compare these two forms for the equation, in statistics, usually you write this of the equation in the form y is equal to b plus mx. So whenever you see a regression equation written, I know it's backwards from what you may remember, but the constant is written first, and the term with the variable and the slope is written second. So that's just something to kind of get used to. So here's the constant, 6.22, and here's the slope, and here's the variable. Okay, so what's the regression equation used for? Well, if we wanted to, we could use it to predict the width of a book if we knew how many pages it has. Now, there's a note here that says don't extrapolate. So what that means is that when you have a regression equation, you can use it in the neighborhood of where your data is. So we have data roughly, I'd say, from about, I don't know, say about 50-ish to about 1,000. So you could use this equation to predict the width of a book when the number of pages is somewhere between, I'd say, about 50, and again, this is approximate, to about 1,000. We should not use this equation to predict the width of a book that has, say, 1,500 pages. Why not? Well, we see data here, but we don't know that the data pattern continues. So out here, say at 1,500, we have no idea what the data looks like out there. Maybe it declines, maybe it flattens out, we just don't know. So extrapolation is when you're trying to use the regression equation to predict values that are beyond the scope of your data. And the big message here is don't do it. Don't extrapolate. You can use this equation to predict any values within this range here, but farther out than that, excuse me, you shouldn't use the regression equation. That's called extrapolation. Now you may wonder, well, how do you find the constant And how do you find the slope? Well, as always, there are formulas for both of these things, all right? But we're going to use technology to do this because the calculations by hand are truly hideous. But technology, SPSS, will provide these numbers for us. And what this line is the line, which is also called, by the way, the least squares regression line. And it's the line such that the distance from the line to all of the points of your data is as small as possible. Like any other line, and this is just a terrible sketch, but any other line, if we made true any other line, the distance from that line to these points, the average of these distances would be much larger than the one that was calculated for us using technology. Okay? All right. So that's the regression line. So it's the line of best fit. It's the line that minimizes the distance from all of the data points to the line. All right. So let's go ahead and take a look at what we're going to learn about the regression line. So a couple of notes about it. The order matters. This is really important. If you switch X and Y, you get completely different results for your constant and your slope. The slope is always meaningful, meaning you can always interpret the slope. The y-intercept is not always meaningful, and we'll talk about what that means when we do our first example. The x variable is given certain names, and you've seen some of these names before, the explanatory variable or the independent variable in your data. That's what we use for x. And the dependent variable or the response variable, that's what we use for y. Now, there are other correlation coefficients. The one that we're studying is the Pearson correlation coefficient, but there's also a Spearman correlation coefficient, a phi correlation coefficient, but the most common one that is used in research is the Pearson correlation coefficient, or in other words, R. So we talked about how you report correlation results, how to report regression results in APA's format. There's a couple of things that you include: the value for R squared, which we talked about before, something called your F statistic. Your F statistic just informs you that there is or is not a significant correlation between your two variables, the degrees of freedom in parentheses, and the p-value. And so here's the format. So here's your statement about the correlation or regression. SAT scores, predicted college GPA. Those are your two variables, your dependent variable and your response variable. Your R squared value, F with the degrees of freedom inside parentheses, your F statistic, and then your p-value. And all of this is just found in your technology output. So let's take a look at an example. So previously, we looked at this example where we found that there was a correlation between the budget of a movie and the gross of the movie, how much money the movie made. Okay, so here was our correlation coefficient. And so that's what we've done up till now. So let's take a look at reporting then the regression movie data in APA format. So our two variables are budget and domestic gross. So budget was our independent variable. So budget predicted domestic gross for movies. Our R squared value, here's right here, is equal to 0.463. Our F statistic is right here. And our degrees of freedom are these two numbers here. So 1, 5020. The F statistic was 4,504.7. And our p-value, here's our p-value. And our p-value, we would report that is less than 0.001, so highly significant. Okay? And we're going to learn how to, as you might expect, how to get that output in our SPS lab this week. Now, What about the equation? Well, the equation numbers, the constant and the slope, are also given in your output from SPSS, and there are the numbers here. So here's the constant, in other words, the y-intercept, and this other number here is the slope. So if I wanted to write the equation, I could say that domestic gross is predicted by taking the constant and adding on, here's the slope, times the budget of the film. And so you can recreate the regression equation also from the output in SPSS. What would you use this for? You would use this to make predictions. So for example, if you knew the budget of a movie, could we predict how much money it's going to make? So given the budget of the movie, we would input that here into the equation, use a calculator and work that all out, and we could predict how much money the movie was going to make. And again, we can only do this because we know there is a significant relationship already between these two variables. Because if there was no relationship between them, if we hadn't done the first part of class where we found out that the R value was significant, then we should not go ahead and do this regression analysis. Because remember, we should only do this if there's a significant correlation between the variables.